So good morning. Today we are going to start our next last topic, fermented food. We know that fermentation is a process where the substrate is converting into the product by enzymes, and these enzymes basically released by the microorganism. So using microorganism, we are fermenting various type of food, and we are producing various type of food product. So these are all type of food which is prepared by the or produced by the fermentation. We are calling fermented food because these products are rich in nutrition, rich in fragrance, and different type of fermented food is there, and these food is available in the market, and you can also prepare in your home. These fermented food and different type of localized food prepared by the fermentation we will discuss in this topic. So first we will see how and what is fermentation and how we can prepare the fermented food. So fermentation is a food processing. Basically, fermentation process is a process where we are raw material like food raw material we are converting into the processed food. Okay, that's why we are calling food processing. It is a conversion of carbohydrate to alcohol and carbon dioxide and other organic acid. And mainly we are utilizing yeast, bacteria, and combination of these two. And basically under the aerobic and anaerobic condition. What type of condition we are now utilizing? Not only anaerobic condition, but aerobic condition also we are utilizing. See where the carbohydrate is converting into the food grain which is having the carbohydrate, and they are converting into the alcohol and more carbon dioxide they will produce, and then we will prepare the bread. So that reaction is under the aerobic condition. So aerobic and anaerobic both type of condition we are utilizing for food processing. So we know that these are all type of food, they are having some amount of carbohydrate, and these carbohydrate using microorganism we are converting into the alcohol, aldehyde, and other type of acids, and carbon dioxide, and so these are all acids, alcohol. They are all utilizing for the process purpose, and they are increasing the flavor, fragrance, and nutrition of the. So fermentation is simple term in a chemical conversion of the sugar into alcohol and aldehydes and carbon dioxides, and different type of, not only ethanol but other type of alcohol also we are producing using fermentation. So the science of fermentation is known as a zymology and zymurgi, because here we are utilizing enzymes. How we are utilizing enzyme? When we are mixing yeast and bacteria, these yeast and bacteria they are producing enzymes, and those enzymes they will digest the carbohydrate into the alcohol and aldehyde, and then we are utilizing as a food product. Now some example is there, and these are all example. Fermented milk product is there: yogurt, cheese, kefir, buttermilk, sour cream, and acidophilus milk is there, and many more other localized product is there. Many fatty acids like ghee product we are preparing using this fermentation only. So other type of fermented product also there like bread, idli, sauerkraut, kimchi, natto, fermented meat product, sourdough, dog bread, miso. So these are all another type of fermented product. This is where the initial ingredient is not the milk. It is different type of initial ingredient. That's why ultimately when we have fermented product, so the ultimate final product will be different. Now we will start with the bread production and role of the microbes in it. So ingredient of the bread, we know it is very simple type of ingredient. Flour we have to take, and in the flour we have to mix the yeast, and yeast is a rising agent we are mixing. So flour is containing a very specific type of protein we are calling gluten. So gluten is to help the elasticity and stretchability, it will increase of the dough. When we are preparing dough of the gluten enriched type of flour, so yeast what it will do, it will enhance the elasticity of the dough. And when we are mixing the yeast also work as a raising agent, because when the flour containing carbohydrate, it will utilize as an energy source. So these yeast, it will produce carbon dioxide, and these carbon dioxide, it will leave from the dough, because it is gas, so it will release, so that you have raised type of dough. And when you will bake it, so that what will happen, the fluffy and soft bread will be ready. So because of the yeast, it is a living organism, so it required a correct condition. So to grow the yeast inside the flour and it will digest it, you have to incubate on a correct temperature and the correct environment. Then only it will produce the carbon dioxide, or it will digest the carbohydrate present in the flour. So that's why it required a correct incubation temperature and condition, and that's why it will produce carbon dioxide. So other ingredient, we are adding salt, and salt is basically we are adding because we have to produce the flavor. So this ingredient is used in a small quantity, and too much of this ingredient will stop the yeast to form the growing. And when we are using a perfect quantity of the salt, so that the flavor of the bread will be enhanced. If we are increasing the salt concentration, so ultimately what will happen, the salt concentration has work as a preservative, and yeast can't able to grow when we are increasing the salt concentration, and yeast can't able to utilize or can't able to ferment the flour, and ultimately your dough will be not ready. So that's why what we are doing, we are limiting the salt concentration in the dough, and then we are doing fermentation, so that what will happen, your fermentation will be optimized, and you have a more raised dough, and you can do cut into the small pieces, and you can give the temperature, so that bread will be prepared. Now how we have to prepare the bread, it depend on the what type of organism you are inoculate. So different type of breads is there. There is not one type on bread. Normally what bread we are using, it is a production of the Saccharomyces cerevisiae, and in normal language we are calling baker's yeast. So the baker's yeast or Saccharomyces cerevisiae is a type of fungi, and this uh, this is not a filamentous fungi. Saccharomyces cerevisiae is not a filamentous fungi. It is a single cell type of fungi, or budding yeast also we are calling. Baker yeast also another name, because mostly these yeast is utilized by the baker. That's why we are calling baker's yeast. So under the aerobic condition, the Saccharomyces cerevisiae utilize the flour and carbohydrate present in the flour, and it will convert, it will ferment it, and it will produce the carbon dioxide. Or when this carbon dioxide will leave from the dough, then the fluffy type of appearance will be there of the bread. So other microbes used to make special bread like sourdough bread, and can be spoiled by the bacillus species that produce ropiness. Ropiness means slimy, sticky nature of the bread. So this slimy or sticky nature will spoil the bread, and because of the bacillus species, different type of species, they will attack on the dough. That's why the bread will be spoiled very easily. So one organism is preparing the bread, Saccharomyces cerevisiae. Saccharomyces cerevisiae is utilizing for preparation of bread, but in other term, bacillus species, different type of species, they are spoiling the bread. Now, how we have to prepare bread in the industry? So first is we are mixing the ingredient in the flour. Flour we have to take, and different type of flour is there, like wheat flour is there, and sorghum flour is there, and you can mix the other type of grain, so that the fragrance and ingredient will be enhanced. So that also you can do, in different type of bread you can prepare. Then you have to add the yeast inside it after the making dough, and you have to rise it after the fermentation. For fermentation, you have to keep for some time, so that the yeast will ferment it. Otherwise, immediately if you will take it and you will cut into the small pieces, and then you are doing baking, or you are putting in the particular temperature for the baking purpose, then fermentation will not happen. So you have to put some time so that the yeast can able to ferment it, and then you have to mold it according to your size, how what type of size you required into the that you have to put it. So you have to mold it into the shapes, different type of shapes, and then you can bake it. So baking can increase the temperature, and you can stop or you can remove the type of Saccharomyces growth, and then you have the same dough which is having raised, and this when it is carbon dioxide is raised the your flour, so that you have a fluffy and soft type of bread. Then you will what you will do, you will cool it down on the normal temperature, and you have to slice it and you just wrap it, and you are selling in the market. So by bread making process is looking wise very simple, but it required some time, at least overnight incubation or 3 to 4 hour incubation it required. It depend on the type of Saccharomyces cerevisiae subspecies we are utilizing. For the industrial level, we are utilizing Saccharomyces cerevisiae subspecies, which is very highly efficient in the in the raising of the flour mixture. Now, one by one step we will see here. In the first step, we will scale and prepare the ingredient. We will weigh the ingredient and we will mix it, and then we will add the yeast, and we will prepare the dough, and using the punching so that the oxygen will be properly mixed, and then again we will put into the fermentation for the 2 3 hours. After the fermentation, we have to scale it again, and then we will prepare the doughing or rounding, so that the bread will be in the perfect shape, and you can change the shape according to your requirement, and then you have to bake it, and then after the baking your bread will be ready, and you if you want you can do slicing, so that according to your required size it will cut it down. So here you can see the different type of industrial processes there, and using these are all mechanized machinery we can able to prepare the industrial level bread. So here you what you have to do in the first step, sponge and dough we have to prepare, and straight dough also we can able to prepare. Quantity you have to utilize for the mixing, you can use bigger size of mixer. You have to put the yeast inside the ingredient, and so that it will be ferment. So mixing quantity wise, and you have to optimize it, how much ingredient you have to take it, and how much yeast you have to mix it. Okay, after the mixing you have to properly ferment it, so that whatever amount of carbohydrate is there in the ingredient, it will ferment. So after the fermentation, the you have to take it out, and you have to dividing and rounding in, so that the dog will be prepare in the small pieces. Then you have to mold it, and according to your shape, how much or how much size is you required, that you have to put into the molding machine. And after the molding machine, the breads will be ready, and then you have to do panning. So panning is a process where the dough or molded product is in the aluminum shaped utensil it will be here, and then you have to do baking, and in these aluminum shaped utensil you have to put into the baking machine, so that at particular temperature your dough will be baked, and then after that you have to cut it into the required size, and then you can do packing also. And this packed bread you can able to sell it in the market. Now two things we have to do when we are having bread. First is prevent and promote. So what we have, the bread required prevention, it will prevent the diabetes when we are utilizing these bread product in our dietary as a dietary product. It will inhibit the diabetes and cardiovascular disease, breast cancer, and gallstones it will inhibit. Then something it is also promote like weight loss, dental and bone health it will promote, and hormonal balance also it will promote, and gastrointestinal health, it will be good. So when we are properly prepared bread we are utilizing, so it will prevent the some type of disease, and it will be good for the now next product. Next fermentation for fermented product is the idli, and we will see how idli is is producing and various type of microbes is utilizing in the production of the idli. So idli made with the ratio of 1:1 with the grain of the rice, and batter volume increase about 47% per 12 to 15 hour after the incubation at 30 degrees centigrade. Black gram or rice powder we have to utilize it for the in the ratio 1:1, means black gram powder or rice powder we have to mix into the 1:1 for 50% we have to mix it. Then we have to prepare dough, and then in the dough we can put the lactic acid bacteria so that this dough will be fermented. Then temperature always normal temperature like 30 to 37 degrees centigrade we can give, and after the fermentation your idli batter or idli solution will be prepared. So the pH fell to 4.5 and total acidity rise to 2.8% as a lactic acid bacteria. So when we are introducing the lactic acid bacteria, so the carbohydrate will be converted into the lactic acids. So flour is having carbohydrate, and that carbohydrate after the fermentation it will convert into the lactic acid. So when lactic acid concentration will be increased, so the pH will be fall down. So using a 1:2 of the black gram of the rice, batter volume increase 113% and acidity will be rise 2.2%. So when we are increasing the carbohydrate concentration, so acidity also will be increased, because more carbohydrate, so bacteria or the lactic acid bacteria can able to digest or can able to ferment the more carbohydrate into the more lactic acid. So the pH will be fall down more. So when we are increasing the rice concentration, rice powder concentration in the idli preparation, so that we can increase the acidity of the dough of the idli. Okay, so reducing sugar showed a steady decrease from 3.3 milligram per gram of dry ingredient to 8.8 milligram of per gram in the 20 hour, reflecting their utilization for acid and gas production. So when we are decreasing the rice powder concentration in the idli powder, so that acidity we can able to decrease. If you want to produce more acidic, more lactic acid in the dough, so what you have to do, you have to increase the rice powder concentration. So you can increase and decrease the rice powder concentration, and you can increase and decrease the acidity in the dough. So soluble solid increase, whereas soluble nitrogen will be decreased. Flatulence causing oligosaccharides such as stachylose and raffinose are completely hydrolyzed. So these two type of saccharide is there, oligosaccharides, and they are completely hydrolyzed by the lactic acid bacteria. So idli and dosa are both product of the natural lactic acid fermentation, and lactic acid mesenteroids and staphylococcus faecalis develop during the soaking and then continue to multiply following grinding. Each eventually reaches more than 1 into 10 to power 9 cell per gram. 1 into 10 to power 9 cell per gram it will reach. So 11 to 13 hour of the fermentation, it will be reached 10 to power 9 cell per gram. So these two species predominate until 23 hour, followed by the batter formation, and practically all batter would be steamed by them. If a batter is further incubated, the lactobacilli and streptococci decrease the number, and pseudomonas after the acidity will increase, so they can't able to survive. So another bacteria, pseudomonas cerevisiae develop, and lactobacillus mesenteroid is the microorganism essential for leavening of the batter, and along with the Staphylococcus faecalis is also responsible for acid production, and both functions are essential for producing a satisfactory effect. So there are three type of bacteria which is preparing in these type of idli making. First one is the lactobacillus, second one is the staphylococcus, and third one is the pseudomonas. So if you want to increase the acidity so that pseudomonas infection we have to, or naturally it will introduce. Otherwise, if you can't able to give the more fermentation time, so these two species, lactobacillus and staphylococcus faecalis, it will do fermentation, and the dough will be ready for the bag for the steaming purpose. So dough is not directly heating, just we are doing the steaming. So using the steaming process, the idli will be ready. Fermented milk product. First we will see the cheese, then shrikhand, kefir, yogurt, and acidophilus milk. We will see one by one. So cheese is made up of casein, and variety of cheese are differentiated according to their flavor, texture, type of milk, and we have to add many things: salt and seasoning added, type of bacteria, mold, species. For the refining purpose we are adding, and manufacturing processing methods also different when we are talking about the different type of cheese. So we are dividing cheese into the three types. First is hard, semi-hard, and soft. So these three type of cheese is there, and hard, semi-hard, and soft type of cheese is prepared when we are inoculating bacteria and molds. So hard, semi-hard, and soft, three type of having two type when we are prepared by the bacteria, and type of molds we are adding. So when we are hard preparing hard type of cheese using bacteria, so we are calling Cheshire or cheddar type of cheese. And when we are more do preparing hard by the mold fermentation, so Stilton type of cheese it will produce. So semi-hard type of refining by the bacteria is Goddard Adam type of cheese, and mold type of refining from when semi-hard type of cheese is produced, it is a Roquefort type of cheese. Then soft three type of cheese we are preparing. Bacterial repelling is a Limburger, mold repelling Camembert type of cheese, and unripened type of cheese is cottage cheese. So these total three type of cheese is there, and different cheese is there, and we hear these are different type of cheese, and these different type of cheese is easily available in the online platform of the, and you can go there and you can able to purchase these different type of cheese. Now we will see the production. So for the initial material we have to take the pasteurized milk, and in the pasteurized milk first we have to form the curd. So after the curd formation we have to do childering, and childering we will discuss how we have to do childering. Then after the childering we have to cut into the or peeling we have to do, so that it will be in the small shape, and we have to put in the milling and salting. So after the milling it will be in the constant type of powder or in the liquid. Then we have to press it, and so that it will be in the structure. Then after the pressing and molding you have to do maturation and curing and preparing. Then we will add different type of bacteria and mold we can utilize for the fermentation. So curd formation you can do by the for that you have to use the pasteurized milk, and the pasteurization you have to do on the for two time of the temperature you have to give. So when you will do the pasteurization, it will be complete lice. So starter and required coloring matter is added after 30 minutes. Renin is added, and renin will prepare the curd. So you have renin is an enzyme, and you have to add these renin in the curd formation. And for when you are mixing these renin in the pasteurized milk, and so that it will be properly mixed, stirrer, and allowed to set curd. Then after the preparation of the curd you have to cut into the small cubes, and this curd cooking you have to do. So after the cube preparation of the curd you have to heat it on 38 degrees centigrade, and After that, held for 45 minutes. So 38 degrees centigrade for 45 minutes. You have to stir it or you have to cook it. After the cooking, the whey will be separate and curd solid part will be separate. So cheddaring is a process where cutting matted curd into the black block, turning them into at the 15-minute interval, and then filling we have to do. It is then passed to curd mill, which cut the slab into the small strips, and we have to add the salt and extra whey we have to separate. The whey is a type of liquid. That liquid you have to separate it so that you can able to easily preserve it. Then you have to ferment overnight. So different type of fermentative bacteria and molds you can add it. So different type of cheese will be ready. Now example of cheese and what type of microorganism we can able to utilize. If suppose you are preparing cottage cheese, so for that Lactococcus lactis and Leuconostoc citrovorum you can utilize. If you are preparing cream, then you have to use Streptococcus cremoris. And you vegetal, if you this type of cheese if you are preparing, then Streptococcus diacetyl lactis you have to use. Then brie, you have to use the Lactococcus lactis, Penicillium candidum, Streptococcus ceremoris, Penicillium camemberti, and Brevibacterium linum. These species you can utilize for the berry type of cheese. Then camembert type of cheese, for you can utilize Lactobacillus lactis, Streptococcus cremoris, Penicillium candidum, Penicillium camembert, and Limburger type of cheese produced by the Lactococcus lactis, Brevibacterium linum, Streptococcus cremoris. Blue type of cheese you can able to produce by the Lactococcus lactis, Penicillium roqueforti, Streptococcus cremoris, Penicillium glaticum. Brick type of cheese, Gorgonzola, Monterey, Munster, and Roquefort, other type of cheese is there. And these different cheese require different type of bacteria and mold treatment. And we can able to prepare after the when we are doing shaping, and we have to remove the whey, and you can able to incubate overnight. So these different type of cheese will be ready for the packaging purpose. Now here you can see the ripen time. So some required overnight ripening. Here you can see they are required soft type of less time, and some are required more ripening time. So 1 to 5 month ripening time is there, 1 to 12 month ripening time is there, and these different type of bacteria and molds, they will increase the flavor, nutrition, and fragrance when you are incubating on correct temperature and correct condition on the correct duration, so that these different type of cheese will be ready. Here 3 to 12 months cheese is there for the Eden, Gruyere, and Swiss type of cheese, and very hard type of cheese is required 12 to 16 month time, and example is Parmesan type of cheese. Now secondary microbes. Primary, when you are adding the microbes, so we are calling primary type of microorganism. After the primary fermentation, you have to use some other type of bacteria and molds, and these type of bacteria and molds can able to enhance further. And these type of secondary microbes, when primary microbes can't able to ferment further, so these secondary type of microbes you have to add it. So large hole, when you are preparing in the fermentation product, so you have to add the secondary type of microbes. Example is Bacterium and Shermani. Where white mold is there, Penicillium camperberti, Penicillium cassiotum, and Penicillium candidum. So different type of molds can able to produce different type of fragrance and characteristics. Color also it will produce. So blue green molds can able to produce the blue green type of cheese. Ripening adjunct like the bacteria, yeast culture we have to add, and when we will add, so the we can able to enhance the more ripening. Then attenuated culture, which are not intended to grow but only to contribute their enzyme. So attenuated type of culture. We are not adding directly these type of culture, but we are producing the enzymes, and those produce product of the enzyme directly we are utilizing in the cheese production. So we are not adding the organism directly, but their product enzymes we are utilizing in the production. Now some microbes involved in the cheese making. So different type of microbes we are utilizing, and for different type of product they are producing. Like Swiss cheese mm, is produced by the Propionibacterium shermani, and it will increase the flavor and eye formation. Eye formation means it will increase the special type of texture, so that people will be attracted and they will buy these type of cheese. Then yogurt and Swiss, Emmental and Italian cheese is produced by the Lactobacillus bulgaricus, Lactobacillus lactis, Lactobacillus haventicus, and it will increase the acid and flavor. Then acidophilus buttermilk is there, and it will increase the acid by the Lactobacillus acidophilus. Then Streptococcus thermophilus, it will increase the acidity of the cheese. And when the acidity will increase, so you have emmental, cheddar, and Italian cheese and yogurt. Then another type of bacteria, Streptococcus durans and Streptococcus faecalis, they are increasing the acidity and flavor of the cheese. And you have soft Italian cheddar and soft some type of Swiss cheese. Then Leuconostoc citrovorum, Leuconostoc dextranicum, they will increase the flavor of the cheese. And you have cultured buttermilk, cottage cheese, and started culture. Now here is the cheese production, how they are doing inside the industry. So first they have to bring the pasteurized milk, or they can directly purchase the milk and they will do the pasteurization. So after the pasteurization, or in many countries traditional cheese they are producing and they are not doing pasteurization. So pasteurized milk or non-pasteurized type of milk, or we can also utilize, and they have different type of flavor. If we will milk the if we will pasteurize the milk, so the different type of flavor will produce. If we will not pasteurize, so a different type of cheese will be produced. So both type of milk we can able to utilize it. So after the standardization and filtration, means after the sterilization, these cheese of this cheese preparation, we have to mix the renin type of enzyme. Renin is an enzyme which will convert into the curd milk. It will convert into the curd. So microorganism we can also mix, and these microorganisms can able to produce the enzymes, and it will convert into the curd. So we have to add the renin or not. So the preparation depend on what type of microorganism we are adding and what type of ultimate type of cheese we are producing. So these type of ingredient we will mix it, and then we have to cut it into the small pieces, or we can do stirring, and when we can do cooking on 35 to 40 degrees centigrade. Then after the cooking, we have to put into the very big size of curd, and then where we will drain it out. So filter is there, and the filter will allow only liquids pass out from this drainage system. Then you have solid part, solid curd, and solid part you have to do milling. Milling will crush into the small pieces, and at that time you have to mix the salt. So salt will you will able to mix it, so that you can able to enhance the flavor of the curd. Then here if you are packing and you are sending for the market, so this type of cheese we are calling fresh cheese, because it is just prepared. And example is cottage and cream cheese. So it is just fermented, and curds we are milling and we are salting it. So that type of cheese is fresh type of cheese. So you can pour these cheese into the mold, different shaped mold, and you have to press it so that it will convert into the particular shape, and it will be very tight. Here you can introduce the primary and secondary type of microbes and molds, and you can able to put for the fermentation repenning, so that microbes and molds can able to ferment from the duration, different duration, and that duration depend on what type of microbes and molds you are adding in the repenning process. So this repenning process depend on the what type of cheese you want to prepare. So this repenning time is depend on the molds and bacteria. Some are required 6 to 12 months, and after the 6 to 12 months you have to keep on the particular condition so that cheese will be ferment, and after the fermentation these cheese will be packed, and you can able to sell in the market. Now repenning. So repenning time is 60 days to 12 months depending on the flavor required under the controlled condition of temperature and humidity. So these control condition, temperature, humidity you have to provide, and these temperature and humidity is according to bacteria and molds. Bacteria can able to grow on the 37 degrees centigrade, and if you are using mold, so they you have to maintain the 28 degrees centigrade, and molds required more humidity compared to bacteria. So changes from bland tough rubbery mass to a full flavored soft product, it depends on the what type of bacteria and molds you are utilizing. Then renin is an enzyme split protein into the peptone and peptide. The protein part of the milk is cut it into the peptone and peptides. So when we will mix and when we will ferment it, so that what will happen, it will increase the vitamin B, and it will improve the cooking quality. So cheese has limited keeping quality and required refrigeration and should be kept in the cold and dry condition. And we are using the wrap wax paper and metal foil so that we can keep from some more time. So cheese has limited keeping quality, and that's why we have to keep into the low temperature for preservation purpose. Now health benefit of the cheese. So cheese contain a host of nutrient like calcium, protein, phosphorus, zinc, vitamin A, vitamin B12. Calcium is one of the nutrient most likely to be lacking in the American diet, and that's why cheese is very important. And the population, if they can able to consume the more cheese, so they will be more nourished. So high quality protein in the cheese provide the body with the essential building block for a strong muscle. If you are lactose intolerant, many cheese product, particularly aged cheese such as cheddar and Swiss, they are contain the little or no lactose, and are often well tolerated. So these type of cheddar and Swiss cheese is very good for the dietary purpose of the lactose intolerant type of people. Now shrikhand. Shrikhand fermented product made by concentrating curd by removing whey and to which sugar, flavor and condiment we are adding. And manufacturing of the shrikhand by the method of manufacture of the shrikhand involves the preparation of curd or dahi by fermentation of milk with starter culture. Then preparation of chakka by the draining way from the curd and blending additive, and we will do the blending by additive like sugar, color, flavor, species and fruit to obtain desired composition and consistency. So here is the shrikhand, different flavored shrikhand. Now, nutritional benefit of the shrikhand. So, presence of calcium aids in bone health. Presence of the calcium make teeth stronger and healthy. Aids in the better sleep and help to gain weight. It help in the absorption of the calcium and vitamin B, and it keep you feel good. Exfoliates the dead skin from body. Gives a smooth skin nourishing with a soft, supple and glowing skin, and reduce the dent. Now type of cultured milk product. So there are two type of milk product we are utilizing. First one is the product of lactic acid fermentation, and second one is product of lactic acid and alcoholic fermentation. So when we are doing lactic acid fermentation, we are having thick sour milk, ketiak, sour cream, yogurt, Tavro type of curd, and Raisenka. So these are all product is prepared by the lactic acid fermentation. And when we are having both lactic acid and alcoholic fermentation, so we are having kefir, humus, acidophilus, and sugar. So these are all product is fermented by the lactic acid and alcoholic fermentation. Now next product is the kefir. Kefir is a beverage produced by the action of lactic acid bacteria, yeast, and acetic acid bacteria on milk, which produce a distinctive firm and red milk product with unique properties. So it is produced by adding a starter culture called kefir grain, and these kefir grain directly we are adding to the milk. So caffeine grains are a mass of several different type bacteria and the yeast embedded in they are the embedded in the complex matrix of the carbohydrate. So the kefir grain are a mass of several different bacteria and yeast embedded in the complex mixed matrix of protein and carbohydrate, and they are directly adding into the milk. So traditionally prepared kefir contain 1 to 2% alcohol due to the complex fermentative process of kefir grains, but new and improved production method will result in much lower quantity of the alcohol. So mouthfeel of kefir is described to be prickly and sparkly. Now method of the kefir production. So first we have to prepare the soy milk of the kefir grain. So milk caffeine ring and water caffeine ring, these two type of caffeine kefir grains we will prepare. And then next step, study different soy milk kefir like characteristic physical characteristic pH, titratable acidity, reducing sugar or alcohol we have to characterize. Then microorganism like lactic acid bacteria and yeast we are adding for the kefir production. Next is yogurt. Yogurt is a variety of curd and whole low fat skim milk and even cream can be used to make yogurt. In production of yogurt, a mixture culture of Streptococcus thermophilus, Lactobacillus acidophilus is usually added to the pasteurized milk, and after the adding we have to incubate at 42 to 46 degrees centigrade. So it will increase the folic acid concentration during the fermentation. Fermented milk is useful for a wide variety of disorder like colitis, constipation, diarrhea, gastroenteritis, diabetes, and hypercholesteremia. Now making of the yogurt. So milk containing lactose we have to use for the initial production of the yogurt, and we will add the lactic acid bacteria in the milk. Lactic acid bacteria in the milk. The bacteria feed off lactose in the milk, and then lactic acid produce increases the milk acidity. Then after the increasing of the milk acidity, milk protein casein will be thickened and coagulate to produce the yogurt. Now yogurt is a probiotic food. Yogurt is basically probiotic food with live and active cultures. It contains different kinds of bacteria that are believed to be beneficial for your overall health. So four major strains of the bacteria we are looking for like Lactobacillus acidophilus, Lactobacillus bulgaricus, Streptococcus thermophilus, and Bidofobacterium. Like acidophilus milk. Acidophilus milk, also known as sweet acidophilus milk or probiotic milk that has been fortified with the Lactobacillus acidophilus or other friendly bacteria cultures such as Lactobacillus bulgaricus, bifidum, or Streptococcus thermophilus. These different type of microorganisms we are utilizing in the production of acidophilus milk. Next is lactose intolerance. Lactose intolerance, also called lactase deficiency or hypolactasia. It is the inability to digest lactose, a sugar found in the milk, and some dairy product. So the people which can't able to digest the lactose, we are calling lactose intolerance because they can't able to produce the lactase, and lactase can when lactase is not there, so they can't able to digest the lactose. That's why we are calling lactose intolerant or lactase deficiency. So what type of symptom they are having, like abdomen, they whenever they are eating the lactose containing the product, so they are having symptom like abdominal bloating and cramp, flatulence, diarrhea, nausea, borborygmi, rumbling stomach, and vomiting after consuming significant amount of the lactose. Now we will see how these lactose tolerant and lactose intolerant is working. When our digestive system is having lactase, or our body is producing the lactase enzyme, so when we are taking the lactose as a food material, so lactose will be digested into the glucose and galactose, and these glucose and galactose directly absorbed by the our normal intestine. But if lactose intolerance type of people, they can't able to produce this lactase enzyme, so lactose will be there in the food material, and our intestine is having many type of bacteria. These bacteria will utilize and digest the lactose into the gases, organic acid, other osmotically acting molecules, and these type of gases or organic acid will produce the irritation, and it will increase motility of the bacteria, and it will cause the problem. That's why it is very important for the those people which is having lactose intolerance, so they have to reduce the lactose type of food, because if they will eat the lactose type of food, so the bacteria will ferment and they have a problem in the digestion related problem. Now some important books for the further study. First book is Fermented Foods, Biochemistry and Biotechnology by Didier Montet and Ramesh Chire. Second book is Microbiology of Fermented Foods by Wood Brian JB. Then Microbiology and Technology for Fermented Foods by Robert W. Hutkins. So these are all some important books. Now we'll see the some multiple choice questions. Which of the following is not the property of the fermented food? Option A, highly nutrition. Option B, toxic. Option C, anti-toxicity. Option D, anti-nutrient. So you have to select the any one correct answer. Next question: the partial fermentation of green tea result in the formation of option A yogurt, option B sauerkraut, option C kombucha, option D kefir. So again you have to select some options. Then next question: kombucha is beneficial for space patient. So option A high blood pressure, option B cardiac, option C low blood pressure, option D diabetes. So again you have to select the correct answer. And next question, which of the following is produced by fermenting soya beans? Option A yogurt, option B kombucha, option C miso, option D jiangs. Then again you have to select the correct answer. Then next question, where did kefir originate? Option A America, option B Canada, option C Europe, option D London. So again you have to select the correct answer. And thank you being with us. See you in the next class. Thank you.